happy Thursday. I'm so excited. We are coming to the end of our first week of instruction. Today will be the last day that we'll have video lessons. Tomorrow we'll be just practicing some problems just to get us, practicing what we're doing. All right, so we have been talking about factoring polynomials, and we've been using area models. So now that you know that you can create an area model for a polynomial expression to help you factor the polynomial, but as you learned when multiplying polynomials, sometimes constructing area tile models is not appropriate for the situation. How can you translate these patterns from a tile model to an algebraic one? Study this animation to see one approach. All right, so we've learned this. Here are the rectangles that you built with area tiles for the polynomials. How could you factor these polynomials without building tiles? All right, so we're going to look at this. How can we do this using algebra instead of factoring with area models? All right, so they wrote them out. You could still use the area model, but not use algebra tiles, right? We could just factoring in the reverse the area model for multiplication that you used in the last topic. So we could just use our numbers. So let's continue. So we have here x squared plus 5x plus 6. Took an x and a 2. These two greatest common factors form one of the factors of the trinomial. These two greatest common factors form the other factor of the trinomial. All right, so they kind of found the greatest common factor of the columns and the rows. All right, so the common factor for this column is x. This one has an x and this one has an x, so that's the common factor for this one. All right, the common factor for this one is they both have 3. We could divide this one by 3 and we could divide this one by 3, so that's a 3. All right, this row, the greatest common factor of both is this one has an x and this one has an x, so the greatest common factor is an x. Right here, the greatest common factor is 2. Both of these can be divided by 2, so they have a 2, and that's how they came up with those numbers. All right, apply the same process to factor this trinomial. When you're done, click check your work. All right, so I want you to pause for a minute. I want to see if you can come up with the greatest common factors for these trinomials. Take a minute and try and figure it out before you move forward. Just pause it and you do it, and then we'll start again. Okay, so if you're looking at this column right here, the greatest common factor, you would have an x. All right, and then here, 3, 9. The 3 is a factor in both of them, so we can have 3, so x and 3. Right here, it would be x again. And then right here, it would be 3 again. All right, and so maybe you're wondering, like, how did they know they were pluses? Well, we factored out a positive 3. If we were going to factor out a negative 3, then that would change them to subtraction. All right, so now I want you to pause this video again, and I want you to work this problem. What have we learned so far in this that we could factor out this? All right, you pause it. Now we're back. The common thing, this column right here is x. So we're still going to put an x right there. The thing out of this one is the same. All right, so we could divide both of these by positive 2. You could divide this by 2, and you could divide this by 2. You can still pull positive 2. All right, but if we're going to go to the rows, which is our first factor, these 2 are x. And what can we pull out of these 2? Well, this can be divided by negative 2, and this can be divided by negative 2. So let's check it. All right. So it still worked the same way for that. All right. So as we move forward through this, I want you working your go formative problems. We're working our problems 5, 6, and 7 on that sheet. Construct a second degree polynomial into 4 terms. You can reverse the box method to find factors, but how can you find 4 terms when often you only have 2 or 3? All right, so it's like how did they take our equation, this x squared plus 5x plus 6, and turn it into this area model? What can we do here? So study these 3 examples, then answer these questions about what each part of the box for second degree polynomials are. All right, so I want you to take a minute and I want you to, this is on your go formative. I want you to take a minute and I want you to see what you think about this. What would you put here in part 1? Which term of the polynomial goes here? The ax squared, the bx, or the c? And it would be the ax squared. Every single time, for every single problem, this number went here, or this term. All right, now what about this one? Which term of the polynomial goes here? In the very last square box, which term goes here? This one has a 6, this one has a 9, and this one has a -4. Is it the ax squared, the bx, or the c? And because I know how smart you guys are, I know that you chose C. You can see that. So we already know what those 2 boxes are filled with. So the first term would be in the top left box, and the last term is going to be in the lower right box. So how are the contents of parts 2 and 3 of the box related to the contents of part 1 and part 4? So let's look at this first one up here. This one has a 2x and a 3x. How is this related to the first one and the second one? Okay, this is your answer to number 6, so I need you to make sure that you're doing your go formative. And hopefully you were able to come out that the product of these contents of parts 2 and 3 is the same as the products of the contents of parts 1 and 4. So if you take and you multiply these 2 together, it would be the same as if you multiply these 2 together. All right, and that goes the same as all of them. 9 and x squared equals 9x squared, and 3 times x times 3x equals 9x squared. We move myself out of the way here. We can do -4x squared, and this would be -4x squared. So how are the contents of parts 2 and 3 related to the middle term, bx? So in this middle, we have bx. How are contents 2 and 3 related to the middle term? So how is these 2 boxes related to the 5x? Take a minute. I want you thinking about it before we go over it. And I want you to answer number 7 on your go formative. All right, so we know the sum of these contents of parts 2 and 3 is equal to bx, so the middle term. So the sum is adding. So if you add these 2 together, 2x plus 3x equals 5x, you get your middle term right here. So when you're trying to solve these things, then that's how you come up with your area models. All right, so please make sure we're having another live video today at 2:10. I want to see everybody there. Remember, you are earning points this week On Sunday, I am picking another person to give my Star Award out to. I got my envelopes ready to mail out, so I just need somebody's name to put on the envelope. And don't be the one that doesn't get one. Try and beat out the other people that seems to be getting all their work done. You can do this too. All right. I expect everybody to have their assignments done by Sunday. Tomorrow you will have Khan Academy assignments ready to go. Those have to be done by Sunday as well. And I will see you next week. If you need me, you got contact. I'll see you this afternoon at 2:10, and then we'll close out the week.